Hey, so I want to do a few problems because I don't know how much time I will have to talk about problems on the first day of class. I always lose a little bit of time talking about the syllabus, structure of the course. I try not to bombard you guys with information on the first day or overly so. The first thing that gets cut off is homework problems. So I thought maybe I'll just make a supplemental video of doing a few problems. Hopefully later in the future, um, in the course, we'll be able to just do problems during class. But since we only meet half time, I gotta lose time somewhere, so usually it's doing the problems. Let's look at the first problem of the first homework. Okay, so what is it we're learning? Well, the thing that we're learning is problem solving, which is a pretty vague statement, okay? Anyway, when we have two pieces of rope end to end, their combined length is 150. When two pieces are placed side by side, one is 38 feet longer than the other. What is the length of the longest piece? You will probably have different numbers on your homework. Again, we're trying to understand problem solving. So I think if you can, on a problem, drawing a picture, figuring that out from there might be the way to go. We have one piece that's longer than the other, so imagine I cut this and then now it's one long piece. So if you add those pieces together, you get 150 feet. Okay, that's the idea. If you put those pieces together, like it, side by side like this, then one of them is 38 feet longer than the other. Now, my mind goes to, after looking at this problem for a while, that we have two pieces that are the same length and then plus 38, and this has to add up to 150. So the way I look at this is we have 2 times some number or some length or whatever, A, B, N, whatever you want to call this. We have two of them, 2x plus 38 equals 150. Okay, so that should do it, right? I mean, that should be okay. All right. So if that's the case, let's think about this. We have 150 minus 38 divided by 2 is 56. Okay, I think that's the length of this guy. This is 56, this is 56, plus 38. Okay, so 56, 38, 94. So I think the longer piece, which is what my question asked, was 34. Okay, what we're learning is problem solving. Also, Polia's um, 4 easy steps to solving any problem. So, it's fairly easy to solve the problem, but you have to kind of break it down for yourself and understand what to do, and that really truly is the hard part. Anyway, I'll see you on the next problem. Looking at a problem like this, James bought a 16 volt. He bought 16 volts of hardware and they cost $6. There was 3-inch bolt that cost 36 cents, and there's 4-inch bolts that cost 42 cents. How many 3-inch bolts did he buy? So I'm an algebra teacher, so of course I think of algebra problems. So when I see something like this, I'm thinking if I added both types of the bolts together, I get 16. And I'm going to do T plus F because I don't want to write numbers, it'd be too confusing. So T means 3-inch bolt and F means 4-inch bolt. Okay, I know that those add up to 16. Okay. The 36 cents and 42 cents. And that's $6, but we should really think of it as 600 cents. That way everything is whole numbers. Okay, it's easier for me to think in whole numbers than it is for decimals. So that's what I'm going to do for my problem. Okay, trying to solve for 3-inch bulbs. I want t equals some number. T equals some number. Okay. Well, again, I'm an algebra teacher, so I have two equations, two unknowns. So I think, well, if I multiplied the top number by negative 42, these would cancel. So I'm going to say negative 42t minus 42f equals 16 times 42. What's that? 672. Perhaps I should check my arithmetic. I think that's right. Okay, now if I add these together, I get negative 72. I get 0, that was the point. And then here I get negative 6. Yeah, and that's t. Okay, so I've discovered that negative 6t equals negative 72. T equals 12. So that's how many we must have bought. And then if we knew that information, now we can easily find, well, this is how many 4-inch bulbs, right? They have to add to 16, so that one must be 4, but my question didn't ask that. So if you're having trouble with that problem, hopefully that helps. Okay, question 4. There's 3 numbers. The first number is twice that of the second number. The third number is twice the first number. The sum of the numbers is 98. You may find it helpful to draw. Okay, again, I'm an algebra teacher, so of course I think of an algebra problem. So I'm thinking, okay, if the first number is twice the second, I'm just going to use A, B, C. Okay, so A is the first, B is the second, C is the third. Okay, so the first number is twice the second. Okay, the third number is twice the first. And the sum of the numbers, oops, is 98. Okay, cool. Now A is 2B plus B plus, it sure would be nice if I could write C in terms of B. And I see that C equals 2A, A equals 2B. So C must be 4B. Okay, so 4, 5, 6, 7. 7B equals 98. B equals 7 divides 98. 1, 7, 2, 8, 14. Okay, so I have B equals 14. Now, A is 2 times 14, which is 28. A equals 28. Third number is twice this. So what's that? 16 and 40 gives me 56. C is 56. Okay, so hopefully you found that helpful. All right, we got a ship problem here. There were ships with 3 masts and ships with 4 masts at the exposition. Okay, so Millie counted a total of 30 masts on 9 ships. All right, very similar to the other problem I did. I'm gonna call T 3 masts, F 4 masts. Hopefully that makes it's kind of like my bolt question. We saw 9 ships. This has 3, this has 4, and we saw 30. solve for the format. So I'm going to solve for f. Okay, so I want the t's to go to 0. So what I'm going to do is I'm going to multiply this equation by -3. That'd be -27. 3t plus 4f equals 30. This goes to 0. We get a single f equals 3. So 4 mass is 3. Okay. All right. Well, hopefully that helps. Looking at question 8, we're looking at sets of a Venn diagram. They asked me about the intersection of R and S. So I want to know, what do they have in common? R and S have 2 and 3 in common. So I would choose 2 and 3. Okay. The next question asked me about T or R. T or R. That's everything in T, everything in R. So all of these T numbers, all of these R numbers need to be included. So that's 1, 2, 3, 4, 6, 7. Okay. 1, 2, 3, 4, 6, 7. Okay. And then my last question was R or S and T. So that's what they have in common with T. Everything that R has in common with T, everything that S has in common with T. So that'd be 2, 3, 4. That's what I need. 2, 3, 4. Whoops. Up. Excuse me. Okay. Everything that has in common with T. Excuse me. 3, 4, 6. Right there. Those are the intersections right there. Right there is that little sliver. That's what we want. Sorry about misspeaking there. Hopefully it's still helpful. Question 9, I have the universal set. That's everything that's included in this problem, 0 through 7. I have set A, set B, set C. My question asked, what is the intersection between A and C? What do they have in common? What does A have in common with C? Okay. My C, they didn't write it in order, which is kind of aggravating that they would do that. I wish that they would just write it in order. It is equivalent, but it's kind of annoying. So anyway, what do these have in common? It seems like they have 2 in common. It seems like they have 4 in common, and it seems like that's it. So A union C, I'm sorry, intersect C, it's 2 and 4. That looks better. All right, now I have C complement, which is not C or B. That's what I want to look at. Well, you don't have to, but it might be helpful to look at where that is using the Venn diagram. You may find it helpful. So with not C or B, we want all of not C and all of B. Okay, so I want all of B to be included. So all of B, even though that part included C, I want it. I want all of B because this is OR. And then I want all of not C that hasn't already been labeled. Okay, so what I do not want is I don't want the pieces that are just C, that's like unique to C, and then I don't want this little piece over here, which is the part of A that has to do with C. Anyway, that's what I don't want. Okay, so I want all of B would be included, so that's 1, 3, 5, 7. Okay, I need anything in A that hasn't already been included, but I want to avoid things that have in common with C. So I want the part of A that doesn't have anything to do with C. I have a 0 that doesn't have anything to do with C. 2 they have in common. 3 is not included. 4 they have in common, but 6 they don't. So I'm going to put those in. Now, I think that's everything, right? Is there anything outside of both A and B and C? 0, 1, 2, 3, 4, 5, 6, 7. And 7 was included with B. So I think this is it. 0, 1, 3, 5, 6, 7. Yeah, this is the answer. Okay, so hopefully me walking through that helps you with your problem. Okay, so question 10. I have set A has 19 elements, set B has 7 elements. What's the maximum number of elements in their union? In my head, if they're completely disjoint, if they have nothing to do with one another, if I drew a Venn diagram, it looked like this. This is A, this is B. They have nothing to do with each other. The the most would be their sum. So it would be 19 plus 7, which is 26. Okay. What's the maximum number of their intersection? Well, if B has 7 elements and the other one has 19, the maximum would be the amount of the smaller one. Because what if B was a subset of A? That's how I'm thinking of it. So it would be all of B would be the maximum that could be. Okay. Hopefully that helps. So this is my question 11. It wants us to look at this Venn diagram. It wants A intersect B complement. Now, something about me, over time, different books I've read, it makes more sense to think of it as A minus B. If you think of the set A and you subtract what they have in common, what's left is their difference, it's 1. So this is like set subtraction, okay? When I read that once upon a time, it made a lot of sense to me, so I still think about that. All right, what is A complement union B? So that's all of B. I want to include all of B and then anything I left behind. So all of B gets included and then everything that's not in A already. So 4. So I got 2, 3, 4 for mine. Okay. Second part. A union C complement union B. All right. So we want everything in A, even though it has parts to do with C. That's fine. Everything with B, even though some of it has to do with C, that's okay because this is union. And then anything that's left over that's not C, we should add in. So it looks like everything but 7 is the way to go. Everything but 7. Okay, so that's that. Last one for me. A intersect B complement. The way McGraw-Hill makes their homework, it's very hard for me to see. Even with my glasses on, it's hard to see. Okay, A intersect B complement intersect C. Again, I think of this as A minus B, and then I want to know what does that have in common with C. So the part that has nothing to do with B, the A, has in common with C is just the number 5. Complicated way of saying it, that's for sure, but that's what I think it is. Okay, so this is problem 19. I like this problem, but there's a lot of different versions. So this one version is only 5 sides. Okay. What's the number of degrees in one vertex angle of a regular polygon with 5 sides? Okay. So I'm pretty bad drawer. See if I can Let's see if I can do it. 1, 2, 3, 4, 5, 6. Shoot. What did I do? Alright, I have to draw a star, sorry. Apologies to the audience here. Told you I was a bad drawer. Alright, there you go. It's pretty rough. Okay. 5 sides. Now, what I want to show you with this, um, proven theorem, but with the number of sides, let's call it n. N equals 5. There's 5 sides. One of the proofs that has been discovered over time is that you can think about how many triangles could exist inside this, right? So what I mean by triangles, I should explain that. So what I mean by triangles is that would connect it, right? So you have a triangle like this. Oops, I can't even draw a triangle today. Okay, but triangle that could connect it. How many could exist? Well, the way it's going to exist is n minus 2. That's how many triangles you can have at one time. So how many degrees are in a triangle? So each triangle has 180 degrees. Right? Fine. So that means there's 5 minus 2. There's 3 triangles that could exist. So that's 3 times 180 degrees. Okay. 300 plus another 240 gives me 540. That has to be distributed over 5, right? So that would be 108? Yes, 180 degrees. Okay, so that's how you do 5. The polygon has to be more than 3 for this to work, okay? So I'm wondering if I refresh this problem, can I have a new problem? Oh, 8 sides, cool. All right, so 8 sides. If this works, n equals 8. N minus 2 is 6. Okay, so then I think there can be 6 triangles at once. 6 times 180. What is that? That is 600 plus another 1080. And then that's distributed over 8. I think that's 135. Let's see. Yeah. Okay. Let's see if I can get another version. I know there's versions of it where it's like 36. 9 sides. Okay, I want to do one that's bigger though. 8 sides. Why are you being difficult on me? Come on. I know there's one that's like bigger. 9 sides. What an exciting video. 10 sides. Okay, well, I think it works, right? I think it's going to work. I think you're going to have n equals 10. N minus 2, in this case, would be 8. 8 times 180 degrees. 800 plus another 640. And that's distributed over 10, so that'd be 144. Cool. Okay, I swear there was one with a really big number. 5 sides again. I think there was one with like 36 sides. 15 sides is pretty big. Um, n minus 2 is 13. 13 times 180 would be 23 degrees divided by 15. Be 156 degrees. All right, well, hopefully that helps. All right, last problem, but I kind of like it, so I hope I can explain it well. All right, so the following tower has 5 tiles and 5 rows. So we see 1, 2, 3, 4, 5. Makes sense, that's what they said it was. Okay, going up, what do we have? 1, 2, 3, 4, 5. Okay, and they always go down, 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 down. Okay, so 5, 4, 3, 2, 1. All right. Now, I don't expect you to know this, but I'm going to show it to you. Um, that follows a pattern, right? I mean, that certainly follows a pattern. Let's say that this is n. If n was 5, what do we have? 5 plus 5 minus 1 plus 5 minus 2 plus all the way down to 5 minus 5. And we see that that's 15. So that follows a certain pattern, that's for sure. They want me to do 23. Okay. So you could do 23 plus 22 plus 21, all the way down to plus 0 equals 276. But I want to show you this theorem. Okay. So n plus n minus 1 plus n minus 2 plus blah, 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 all the way down to n minus n, which is 0, which is adding 0 to n. Okay. This has been proven many, many times that this can be written as n plus 1 divided by 2. It's really cool, okay? It's really cool that that works. So that means you can add up all of the numbers, you know, that you want as long as it's a finite amount. Okay. So if we have something like 23, we can say, okay, I just need to go 23 times 24 divided by 2, which is 276. That's pretty cool that you can do that. You can do this one. This one's huge, right? 240 times 241 divided by 2. All right, really cool that you can do that, right? So this is a really cool theorem that that actually works, right? So you could add up all the numbers from like 1 to 100 doing this, like 1 plus 2 plus 3 plus 100. You can do that now. You can go 100 times 101 divided by 2. Much easier to do, right? Much easier to do. All right, I thought I would show that. It's not really like, um, I mean this first homework is so like just the stew of random ingredients of problem solving. But because of that, we don't always have time to like go over every problem. So I thought maybe this would be helpful to you, maybe not. If it wasn't, I'm sorry. I'll make it up to you next time. All right, speaking of next time, I'll see you then.